Hello there and welcome back. Now that we have our project set up, we're going to start combining our two pieces of footage. Now to combine different elements in Nuke, you need to use the merge node. You can create that by typing merge in your tab viewer or simply by hitting M. This is the most commonly used node in Nuke and you'll be using the shortcut all the time. So let's zoom in here and you'll see we have three inputs into our merge node. We have our A pipe, our B pipe, and our mask pipe, and we're going to go over all of these. So how exactly do we use our merge node? Well, what we do is we take our B input and we'll connect that to our first piece of footage. Let's just get this nice in line here and we'll hit 1 so we can look at that with our viewer. Give ourselves a little room to work. And now we'll connect our A pipe to our second piece of footage. All right, you just noticed a change. We've actually overlaid our read 2 here over our read 1. Just turning this off and on. What exactly is happening here? Well, if you go over to the operation knob, you can see exactly what math Nuke is doing. The default is over, and over means I want what is in pipe A put over pipe B. In this case, that's our footage 2 over our footage 1. If you select this dropdown, you can see all the different ways that you can combine footage together. Throughout this class, we're going to go through the most commonly used merge operations and the ones you'll be using in your day-to-day work. I would honestly say there's only about 4 of these I use each and every day. The rest of them are a little more specialized, and some of them I'm not sure I've ever used. So over is the right operation for this. We have A over B. The other thing we should keep note of currently is this mix slider here. Mix is basically a dissolve saying how much of input A do I want to keep over input B. In this case, we want all of it. So we'll leave that at 1. And that brings us to our next step in this shot, because right now we don't want to see all of footage 2. We only want to see this actor dropped into our original plate here. So how do we do that? There are many different ways to cut out footage in Nuke. One way we're going to look at is by using this mask pipe here. So this mask pipe needs an input, and the input we're going to give it is a roto node. So let's make a roto node by hitting tab, typing in roto. This is a very commonly used node in Nuke, so you can also quickly make it with the shortcut O. All right, so we have this selected here. Let's grab our mask input and pipe it into our roto node. You'll notice that immediately our footage O2 disappears. We can turn this off and on, and there's no change. Because right now, if we look at our roto node, there's nothing in it. We haven't told it what part of our footage O2 we want to keep. So let's go back to our roto node here. Over here, we have a couple different shapes we can use. We can just use the ellipse here really quickly. I have that selected. And I'll just drag and drop there. All right, we can see the bounding box snapped. It's only calculating in this area. And let's go back to our merge and see what happened. All right, that's a start. It's not exactly what we want. We can just grab all our points here by hitting Control A. We'll scoot this over so it's a little more accurate. All right. You can hit play. And the shot is done. So what exactly is happening here? Because if we look at our roto node, it looks blank. But something that you need to keep in mind in Nuke is that right now we're just seeing the red, green, and blue channels. And that's not what determines masking in Nuke. That's your alpha channel. So you can see your alpha channel by hitting A on your keyboard, and it'll pop up and you'll actually see you're saying, hey, this is the mat where I want my footage O2 to be seen. This lines up perfectly. I'm still in alpha. I'll hit A to get back to RGB. This lines up perfectly with our cutout here. Now, a lot of the time when you're working, you don't want to see these shape overlays. So there's a couple ways you could hide it. One is you could just close the roto tab over here and it'll go away. But sometimes you want to be able to quickly turn it off and on, and you don't want to have to go back down into the Roto node and then reopen it again. And so Nuke has a quick shortcut. If you click in your viewer and hit Q, Q stands for overlay off. I don't know why it's Q, but it is, and we'll accept it and move forward. And you can tell in the top left here when your overlay is on or off. So now we have our mask in here. We'll hide our overlays really quick. All right, so this is step 1. We have a mask on our footage. Step 2 is we need to get it to track. Let's look into that. We already determined earlier that our footage 2 is pretty much perfectly stable, so we don't need to stabilize this any further. Footage 1, on the other hand, moves. So let's get started on a track here. We'll start at frame 100. All right. And I'm going to create a tracker node. Nuke's tracker node is a basic 2D point tracker. What that means is you'll feed it a position and it'll try to lock onto that position in X and Y throughout the shot. So let's look at the node settings here. Here we have the tracker tab. This is going to host all of the tracking points that we create, and we can add or delete from here. It's also going to control our exports. So let's add a tracker real quick. We'll hit add track. Let's go full screen here. All right, where is it? Well, if we look up in our top left here, we can see our overlays are still off. So let's turn those on. All right, there our tracker has appeared, and it's actually right around where I want it to be. So this has created a couple of different boxes in our viewer. So the inner box is basically saying, hey, this is the exact pattern that I want to track. While this outer box is saying, look for this pattern within this area. If something is moving very quickly and your search box is very tiny, it's not going to track correctly. So it's very important to note the difference between these two. And over here we have a stabilized view where we can see how sticky our track is. Throughout this workshop, I'm going to say this time and time again, but the best way to check your tracks is by stabilizing them. So to actually start tracking the shot, we have our tracker controls over here. Let's go ahead and track backwards to the start. All right, you can see our tracker fly off. Now our tracker has stopped because if we zoom out a little bit, it's lost the point that it was trying to keep a hold of. You can see as we scrub through here, it's doing a pretty good job sticking right there. You can look in our stabilized view and notice there's not really any bumping happening, which is always a good sign. We can make this stabilized box bigger to see if there's really any micro jitters hidden within our track. So this is looking pretty good here. And I don't really need to track beyond this point where it stopped, because if you think about it, our actor is just down here. So we really don't need to go any further into the beginning. So let's go back to frame 100. You can see here, these blue ticks on our viewer bar means that there's a keyframe. So our tracker has keyframed information on all of these frames that it's tracked. You can also see these keyframes in the dope sheet. You can not only time offset footage in the dope sheet, but its main purpose is adjusting keyframes, and you can see all the keyframes we've created here. Let's go back to our node graph. We'll go back to our track. Let's go ahead and select it here. Now that we have our track selected, let's track forwards. All right, there we go. We can just scrub through here to see how accurate this is. I'm largely looking at our little stabilized box there to see if it's jumping around, but it looks like it's sticking really well. Cool. If we want to see it in the viewer as well, we can also stabilize this here. We can click this button, which is center viewer. You'll see. We'll see here how stable this is. Now I'm noticing a little bit of rotation on the right side. The stabilize never lies. And that's not only a dumb rhyme, but a very true statement. Stabilizing your footage will reveal a lot of potential problems that you can't see when it's fully in motion. As you can see, this tree is drifting, so it looks like we have a little bit of parallax. We'll see if that comes into play later. But for now, we're just trying to get a baseline track, and this is more than good enough. In order to export our track, we'll go down to this Export tab, and there are 8 different options we can choose from. There's corner pins, which we'll get to next week, and then there's transforms. So what this would do is it would make a transform node, and it will apply our tracking data to it. What is a transform node? Let's look at it really quick. Let's just hit this button to clear all of our node properties. We'll click over here, and we'll hit tab and type transform. There we are. The shortcut for transform is also T, which I'll be using from now on. So a transform is another very commonly used node. We can take a look at it quick. It has this little widget here, which allows us to move our footage. All of these are pretty self-explanatory. You can rotate, you can scale, you can skew, and this is all based around that anchor point. If you want to move the anchor point, you can hit Control and drag it around, and now everything will skew, scale, rotate based on that anchor point. So that's what a transform node does. I'm just going to delete that. We'll go back to our tracker, double click to open the properties, and we will go to Transform Match Move. All right, now we have a Transform Match Move node. Now, what is the difference between Match Move and Match Move Baked? You can probably guess what the difference between Stabilize and Match Move are. Match Move will match the motion, where Stabilize will remove the motion. But Match Move versus Match Move Baked, you can see that when we created this, there's a little green arrow going from the tracker into the Match Move. Well, just making a Match Move expression links this transform to this tracker. So any further changes we make, if we need to modify the track for any reason, it'll automatically propagate. It also makes for a much smaller save file, because if you were to hit Baked, it would bake in all of these keyframes that we've made here. Typically, the impact on performance is pretty light, so it all depends on whether or not you want that automatic link. In this case, we do, so I'm just going to leave that there for now. We have our track set up. So let's close out of this and set up a good frame right here. All right. We'll go to the last frame here. Let's take our mix down. We'll use that transform node that we talked about to align our 2 plates. These were shot in the same location, so it should be pretty easy to line them up. You can use the viewer widget, or you can also go into the text box over here and scroll with the middle mouse wheel for fine-tuned adjustments. Make sure that these are really lining up closely. I'm mainly looking at the mountains. All right, that seems pretty good. All right, so we have a good matched frame here. Go back and full screen that. Now, something you may have noticed is now that we've made that transform, our bounding box is just a little bit bigger. That means Nuke is calculating all of this extra data, and we don't want Nuke to do any work that it doesn't have to. So to get rid of this, we can go to our bbox settings. The bounding box is the total amount of pixels that Nuke is calculating. And right now we're saying, hey, calculate the combined bounding box of A and B. You can also have Nuke only calculate where A and B intersect, or you can only calculate A or only B. In this case, we're going to go with B, and our bounding box shrinks down again to a normal size. In this case, it's really not going to speed us up that much, but it's good to have these practices in place for when you start getting into heavier comps. Now that we have that lined up, let's take our mix back up. All right, there's our piece of footage. It's looking like we're gonna have to do a little color correction, but we'll cross that bridge later. So let's take our transform match move and drop it after our transform. Uh-oh. What in the world just happened? Let's work our way down our node tree and investigate. So our transform here, this looks like about where we had it. But this match move has just launched it up, and that's not what we want. We want the reference frame to be 178. And by reference frame, I mean the frame where no movement has taken place. So we can adjust that by going into the tracker node, going to the transform tab, and hit set to current frame. You see this suddenly snapped back down. Let's just clear this so it's a little cleaner. Double check here. So on this frame, now we're not moving any pixels. Let's go back to our merge. That's much better. We'll hide our overlays here using Q. Now when there's an animation, you'll actually have to hit Q twice. Hitting it one time will hide the animation curve, and hitting it the second time will hide all widgets. So we'll go ahead and hit play here. All right, so this is interesting. We can see our track kick in halfway through, but our roto isn't sticking. Well, what can we do about this? You very well could take this match move, copy it, and paste it after this roto, and then suddenly, once our track kicks in, our roto will also stick. But now Nuke is applying the exact same movement twice, and there's a more intelligent way that we can build our node tree. We never want Nuke to work any harder than it has to. So let's just disconnect our mask pipe here. Now we can just see this is tracking in. There's no mask in it. And let's look at another way at masking footage in Nuke. We'll go here. Let's move our footage up. And you can actually mask footage using a merge node. I just hit M there to create that as its main operation. Now I don't want our footage here to be in the A pipe. And that's because of a very fundamental Nuke organizational concept. And that is the B pipe must always flow down. Well, let me tell you why. If we look at our merge 1 here, when you disable a merge node, it's going to reveal pipe B. And all scripts need to be built this way. It becomes very difficult to troubleshoot scripts where the B pipe and A pipe are constantly flip-flopping back and forth, and it allows you to very quickly be able to tell what is going on in your Nuke script. So I cannot stress, having the B pipe be your main downward flow is incredibly important. So we can switch this here. We could disconnect and then connect B, or when you have this node selected, Shift X. We'll swap the inputs. Now we can delete this. We'll move over here and let's combine our A pipe. Oh, what happened here? Well, this is a good example of how alpha affects an image when you're merging elements together. Because if you look at this alpha, it's saying that this is actual image. And here, our actual RGB value of that image is black. So when I just merged this over, it added a black circle. But that's not what we want in this case. We don't want to use over. What we want to use is a merge operation called mask. And what mask does is it takes the alpha input in A and it says, hey, whatever is in pipe B, I only want to see that where I have alpha. This perfectly lines up. Let me just hide these other property windows here. This perfectly lines up with our roto shape. Mask is another operation that I'm constantly using. The sister operation to mask is stencil, and it's the exact opposite. It's saying, hey, where I have alpha in input A, I want you to erase the image. So we'll change this back to mask. And looking at our bounding box again, we could make this more efficient. So since we're only using where A overlaps B, we can actually change this to intersect and it'll calculate even faster. Let's go back to merge here. All right, and now we can see our mask is tracking.
And we were able to get that for free. And that's because of the order of our nodes. We have our footage being read in, we're applying our mask, we're transforming it to line our footage up, and then we're tracking it. Because of this flow of data, we're able to get our footage and the mask to track all with the same transform match move.
Next, we'll look at adjusting the color and the edges of our mask here. But that's all we have for this video. Thank you very much for listening, and I'll catch you in the next one.